Hello all, welcome to the value added course on Python programming for beginners as part of WEEK-10 in this module 14. So already we have discussed about error and exception handling fundamentals, and in this video we are going to discuss about how to raise the exceptions, built-in and user-defined exceptions, and how we can handle exceptions in invocable functions. So coming to the raising exceptions, we can deliberately raise an exception using the raise keyword. So in previous video, we have discussed about try and except blocks. So now we can use this raise keyword. So the general syntax for the raise statement is raise, and we have to give exception and arguments and trace back. So now here we are using square brackets, which will represent these are optional. So here the exception is the name of exception needing to be raised. So that is example type error, keyboard interrupt or anything. And args is optional and specifies a value for the exception argument. If args is not specified, then the exception argument is none. So that is default none. The final argument traceback is also optional, and if present is the traceback object used for the exception. Now this is the example which will demonstrate you deliberately about the how to raise an exception. So here we are raising the try and num equal to 10, print num, and here we are going to raise the value error, raise value error. Now except colon print exception occurred, program terminating. So now for example, we are going to execute this program and we have given print num equal to 10. So simply it will print 10 and exception occurred, program terminating. So because we have raised the error here, so that's why simply it will displace the except block and it will execute exception occurred, program terminating. Now, so another example program to re-raise an exception, try and raise name error except print re-raising the exception and rise. So now see here, whenever we execute this program, so in the try block only after first we have raised the name error, and so that's why it will go to except block, re-raising the exception and trace back. So normally it won't give whenever we handle this exception, but trace back it has given and raise name error, and simply it will print the name error. And how to know instantiating exceptions? Python allow programmers to instantiate an exception first before raising it and add any attributes to it as desired. These attributes can be used to give additional information about the error. To instantiate the exception, the except block may specify a variable after the exception name. The variable then becomes an exception instance with the argument stored in the instance.args. The exception instance also has the string method defined so that the arguments can be printed directly without using the instance.args. The contents of the argument vary based on exception type. Now this is the program to understand the process of instantiating an exception. So now see here, try and raise exception hello world. So here we are giving the two arguments. So except exception of error object, print type of error object. So that means simply it will print the exception instance, and print error object dot args, and whatever argument stored in the dot args it is going to print, and print error object, and that means here it will allow strings argument to be printed directly. So now arg1 comma arg2 equal to error object dot args, and print argument 1 equal to arg1 and print argument 2 equal to arg2. So this is the program, and whenever we execute this program, So here it will print class exception, hello world, and argument 1 equal to hello, and argument 2 equal to world. Okay, so here we have to note important point. If we raise an exception with arguments but do not handle it, then the name of the exception is printed along with its arguments. So this is the second program to raise an exception with arguments. So now try raise exception hello world except value error. So print program terminating. So now what is the output whenever we execute this program? Trace back most recent call last, and it will give the entire path. So file FRMMOOPP unit 5 exceptions rise with arguments.py, and in line 3 we are finding this error. And what is the error? Raise exception hello world. Exception is hello world. Now, how to handle exceptions in invoked functions? So, exceptions can also be handled inside functions that are called in the try block as shown in the program given below. So, now see this program to handle exceptions from an invoked function. So, define, divide num comma denominator, and try quotient equal to num divided by denominator, and print quotient equal to co. Except division 0 error, print, you cannot divide a number by 0, program terminating, and we are calling this method divide 20 comma 0 and divide 20 comma 4. And whenever we run this program, so here also it will handle. So exceptions can also be handled inside functions that are called in the try block as shown in the program given below. Then what is the output? So here whenever we call the first method divide 0 comma 20 comma 0. So now you cannot divide a number by 0 and program is terminating. And for the second method divide 20 comma 4, it is going to print the quotient value 5.0. So this is the method how the exceptions are handled in invoked functions. So now see here the try block invokes a function and it will go for the throw point invoked function that generate an exception. Then it will go for the except block. It will catches the exception and handles the exceptions. So basically, a large program is usually divided into n number of functions. The possibility that the invoked functions may generate an exceptional condition cannot be ignored. So the figure shows the scenario when the function invoked by the try block, it will throw as exception, and this exception is handled by the except block in the calling function. So this is the syntax of such a situation. So here function name and argument list, and we can write our code. Next try. So in the try method, try block, we can call the functions and accept exception name. So here we can write the code for handling the exception. So this is another program to handle exceptions in the calling functions. The same program define divide num comma denominator try. So here quotient equal to num by denominator, print quotient equal to quotient, and accept division 0. So print you cannot divide a number by 0, program terminating. Divide 20 comma 0, divide 20 comma 4. So now this is the function definition and this is the function calling. So whenever we calling the first function divide 20 comma 0. So here you cannot divide a number by 0, program terminating, and quotient 20 comma 4, quotient equal to 2.85714. So next, coming to the next topic, built-in and user-defined exceptions. So here the exceptions are categorized into two types, built-in exceptions and user-defined exceptions. Built-in exceptions. So the next slide lists some standard exceptions that are already defined in Python. These built-in exceptions force our program to output an error when something in it goes wrong. So these are the built-in exceptions. So here the first one is exception. So this is the base class for all the exceptions. And the second one, stop iteration. So this will be generated when the next method of an iterator does not point to any object. And system exit. it is raised by the sys.exit function. And standard error, so this is the base class for all built-in exception, excluding the stop iteration and system exit. Next, coming to the arithmetic error, base class for errors that are generated due to mathematical calculations. Overflow error, raised when the maximum limit of a numeric type is executed during a calculation. Floating point error, it will be raised when a floating point calculation could not be performed. Zero division error, raised when a number is divided by 0. Assertion error is raised when the assert statement fails. Attribute error, raised when attribute reference or assignment fails. EOF error, so there is end of file. So raised when end of file is reached or there is no input for input function. Next one, import error, raised when an import statement fails. Keyboard interrupt, raised when the user interrupts program execution by pressing Ctrl C. Lookup error, base class for all lookup errors. Index error, it will be raised when an index is not found in a sequence. Key error, raised when a key is not found in the dictionary. The name error raised when an identifier is not found in local or global namespace. Unbound local error is raised when an attempt is made to access a local variable in a function or method when no value has been assigned to it. So in the same way, environment error also. And IO error is raised when input or output operation fails. Suppose opening a file does not exist. Then syntax error raised when there is a syntax error in the program. Indentation error is raised when there is an indentation problem in the program. So system error is raised when an internal system error occurs. Value error is raised when the arguments passed to a function are of invalid data type or fetching a list for the non-existent value. Runtime error is raised when the generated error does not fall into any of the above category. Not implemented error is raised when an abstract method that needs to be implemented in an inherited class is not implemented. And final error, type error, raised when two or more data types are mixed without cohesion. So these are all the built-in functions. Next, coming to the user-defined function. So the Python allows us to create our own exceptions by creating a new exception class. The new exception class is derived from the base class exception, which is predefined in Python. So this is the user-defined exception. So here class my error. So this is the class we are going to define, my error, and we are defining this class under the main class exception. So next, define initiation self comma val and self dot val equal to val, and define str self return representation of self dot val. So now we can try raise my error 30. Raise my error 30 except my error as E. So here we are going to define our own exception except my error as E. Print user defined exception generated with value E dot val. So now this is the output. So simply it will displays user defined exception generated with value 30. In this program, the init method of exception class has been overridden by the new class, and the customized exception class can be used to perform any task. However, these classes are usually kept simple and have only limited attributes to provide information about the error to be extracted by handlers for the exception. Now, creating our own exception class or defining a user-defined exception is known as custom exception. And one important point thing we have to remember is An exception can be a string, a class, or an object. Most of the exceptions raised by Python are classes with an argument that is an instance of the class. As is a keyword that allow programmers to name a variable within an except statement. When creating a module that can raise different exceptions, a better approach would be to create a base class for exceptions defined by that module and subclasses to create specific exception classes for different error conditions. So now this is the example, the second example. So here we can create a program for subclasses for exception class to handle exceptions in a better customizing. So now here we are going for creating our own exception. So there is class error exception and we are going to define message. So here error is the user defined class and we are taking we are deriving this error from the exception class. Define message self rise not implemented error and class input error and we are going to define this input error from the error class. So see here input error is deriving from error and the error is deriving from the exception. Now the input error is going to define from the exception error, then define init self expression message and self.expr equal to expr and self.message equal to message. Now define message of self, print error in input in expression, then print self.expr and try a equal to input, enter the value of a, raise input error, input, enter the value of as, input error, and accept input error as ie dot message, ie dot message. So now, whenever we execute this program, what is the output? Enter the value of a. First it will ask, and we have given 20. Then it will raise the input error. Then it will print error in input expression and input of enter the value of a yes. So whatever we have given for this rise, so simply it will print. Now, although there is no naming convention for naming a user defined exception, it is better to define exceptions with the names that end in error to make it consistent with the naming of the standard exceptions. And one important thing is many standard modules define their own exceptions to report errors that may occur in functions they define. So this is about the exception handling. Okay, so we have seen the try block, except block, and rise, and else class, and user defined and predefined exception. Thank you for listening this video. Happy learn.